All right, so in this lesson, we're going to be classifying triangles here. So what we want to be able to do is be able to classify triangles based on two things, the lengths of their sides and their angles. Now, the trick to this is that in these questions, we're not going to be given the lengths of the sides or given the sizes of the angles. So we're going to have to use the length and the slope formulas that we've been developing over the past couple of units and use them to find the lengths of the sides and figure out some stuff about the angles so we can classify these triangles. So before we get into that, here's how we're going to be able to classify them. We can classify triangles based on the lengths of their sides. We can have an equilateral triangle where all three sides are the same length. We can have an isosceles triangle where we have two sides that are the same length. And we have a scalene triangle where all the sides are different lengths. And even working with these terms equilateral, isosceles, and scalene for years now. We can also classify triangles based on the size of their largest angle. So we have what is called an acute triangle, where the largest angle in the triangle is less than 90 degrees. I'll use the words less than 90 degrees. We can have an obtuse triangle over here on the right, where our largest angle is over 90 degrees. And we can have a right angle triangle where our largest angle is exactly equal to 90 degrees. The one that we're going to be interested in most often is the right angle triangle. And basically, we're going to want to figure out whether a triangle is a right triangle or not. And the key for us to classifying these is that if a triangle is a right angle triangle, and we look at these sides here and here, these two sides are perpendicular to each other. Okay, so if we can find when two sides are perpendicular, we're going to know that it's a right triangle. Whereas if none of the sides are perpendicular, it's going to be either acute or obtuse. So no sides. And rather than write the word perpendicular, I'm just going to use this perpendicular symbol here. Okay. So let's do an example where we are given some information about a triangle and we're asked to classify it. So a triangle has vertices A, B, and C, and we're given the coordinates of A, B, and C. And we're asked to do two things here. First, we're asked, is triangle ABC a right triangle? And then we're asked to classify the triangle as scalene, isosceles, or equilateral, again, based on the lengths of the sides. So a good place to start in a question like this is to sketch a little picture of what the triangle looks like. So let's plot our vertices here. We've got vertices at -1, 3. So that's going to be point A right there. B is at 1, 7. So I'm going to put B up there. And C is at 5, 5, which is going to be right there. So I'm just going to draw my triangle A, B, and C. Now, I'm not going to classify it based on the diagram. The diagram is just there to help me sort of visualize the situation. So let's start with the first part. Is triangle A, B, and C a right triangle? Well, we know that if something is a right triangle, two sides are going to be perpendicular. If two sides are perpendicular, we know that their slopes are going to be negative reciprocals. So this suggests that we can use the coordinates of each of the sides of our triangles to find the slope of each side, and then see if any of our sides are perpendicular. Now, when you're doing this kind of question, you want to keep everything organized. So I'm going to start with side A. Let's not do AC first. Let's do AB first because it's our first 2 points. Okay. And I'm just going to use our slope formula. Y2 minus Y1, X2 minus X1. Okay. And I'm going to treat point B as our point X1, sorry, X2 and Y2, and point A is X1, Y1. And I'm just going to sub in those values like we've been doing in all of our other slope calculations. So Y2 is going to be 7, Y1 is going to be 3, X2 is going to be 1, and X1 is negative 1. So when I do this calculation, I'm going to get 4 over 2. So this slide has a slope of 2. Now we're going to have to go ahead here and we are going to do the slopes of the other 2 sides. So AB, let's say, what's our next one? Let's do BC. Again, we're going to use our same slope formula, but what's going to change here is we're going to change which point is our x2 and our y2 and so on and so on. So in this case, if we're doing BC, this is going to be x2, y2, and this is going to be x1, y1. So I'll just sort of, I don't know, let's say this is the blue lettering. This is the green lettering here. So we want to do, again, y2 minus y1, x2 minus x1, y2 is 5, y1 is 7, x2 is 5, x1 is 1, so we get 5 minus 7 is negative 2, 5 minus 1 is 4, so negative 2 over 4, so negative 1/2. Okay. And then finally, we would go ahead and we would calculate the slope of side. Let's do AC. And once again, if we're doing AC, again, we're going to change which one is x2 and which one is y2. So I'm going to say this is x2, y2. This is x1, y1. I'm not going to write out the slope formula again. I'm just going to go right to the letters here. So y2 is going to be 5, y1 is 3, x2 is 5, x1 is negative 1. So we get 2 divided by 6, or 1/3. So we've got all 3 of our slopes here, and we have to ask ourselves, are any of these slopes negative reciprocals of each other? And sure enough, these 2 are, okay? Because I'm just going to point to them, and I'm going to say negative reciprocals. Okay? Because my slope of 2 is 2 over 1. If I flip it over, I get 1 over 2, and I've got the negative sign in there. So because 2 of our sides have slopes that are negative reciprocals, we know that triangle ABC is a right triangle. And there's the first part of our question done. The second part, we're asked to classify the triangle as scalene, isosceles, or equilateral. To do this, we are going to need to calculate the lengths of all 3 sides. So find lengths all 3 sides. So let's start with side AB. And to do this, we're going to be using our length formula here, right off of our formula sheet. This is going to be x2 minus x1 squared, y2 minus y1 squared. And if I'm doing AB, again, x1, y1, x2, y2, we can sub in our values here. So x2 is going to be 1, y1 is going to be -1 squared. That should be a positive sign in the middle there. And then y2 is 7 minus 3 squared. And we can work out what this is. So 1 minus -1 is going to be 2. 7 minus 3 is 4. 2 squared plus 4 squared is 4 plus 16. So root 20, or, I mean, we can leave it as root 20, that's the exact answer. Or if we want to express this as a decimal, we can write this as 4.47. Right? So that's the length of side AB. We want to repeat this for our other two sides. So BC, we can do the length is going to be, and I can see the length formula there, so I'm just going to put in the values for x2 and y2. So if I'm doing BC, my y2, my x2 is going to be 5. My x1 is going to be 1. My y2 is going to be 5. And that's going to be 7. So 5 minus 1 is going to be 4 squared, plus 5 minus 7 is going to be -2 squared. I'm going to get 16 plus 4. Oh, so I get root 20 again. So already I can see that side AB and side BC are going to be the same length. So this triangle is either isosceles or equilateral. It's all going to depend on what we get for the length of side AC. If AC is the same length, it's equilateral. If it's a different length, it'll be isosceles. So let's go ahead and find the length of side AC here. And again, we are going to want to use our length formula. Our x2, our second point is going to be point C here, so I'm going to put in x2 is going to be 5, and y2 is going to be 5. And then we're going to subtract the coordinates of point A, -1, and 3. So we're going to get the square root of 6 squared plus 2 squared, which is going to be the square root of 40, okay, which if we're doing this approximately, we can just punch this into our calculator and we get 6.32. So what can we conclude from this? Well, we've got two sides the same length. Therefore, ABC is isosceles. Now, if we wanted to, we could use the lengths of the sides to verify that it is in fact a right-angled triangle. If it's a right-angled triangle, the sides have to obey the Pythagorean theorem. Which side is going to be C, our hypotenuse? Well, it's got to be our longest side. So that's got to be our root 40. And our a squared plus b squared is going to be, I guess we should think of this as doing like a left side, right side check. A and b are going to be our other two sides. So that's going to be root 20 squared plus root 20 squared. Well, root 40 squared is just going to be 40. Root 20 squared is going to be 20. 20 plus 20 is 40. So because this obeys the Pythagorean theorem, ABC obeys Pythagorean theorem and must be a right triangle. But doing this in addition to finding the slopes of the sides is a little bit of overkill. So if my solution had stopped right there, it would have been perfectly good.